All right, so we are continuing on with section 5.4. We talked about the derivative of e, so naturally today we are going to talk about the integral of e to the power of x. So we're going to be working backwards. So I want you to first of all remember that d, the derivative of e to the power of u, is equal to, what is it equal to?
U.
E to the u times what? Times u prime. Which is the same thing as e to the u power du. Remember, u prime and du mean the same thing. So naturally, because of that, if I ask you guys to work backwards and find the integral of e to the u power du is equal to what? It's going to be e to the u power. The derivative of e to the u power is e to the u power du. So if you find the integral of this, it will be what it is that you started with, e to the u power. Except for finding an integral, so what do we always need to tack on to the end?
Plus c.
Add on a plus c. Yep. So what we're going to do today, the goal here, and it doesn't always work like this, it's just as it didn't always work like this when we were finding the integrals of natural logs. We are going to focus on finding the derivative of the power in this case. So I probably would circle the power. I'm going to put a little note here that you are going to find the derivative of u, which is the power, to see if it matches the du. See if it matches du. First example, find the integral of e to the power of 3x plus 1. I just want to make sure we've had a chance to write all that down. Find the integral of e to the power of 3x plus 1 dx. And just as I said a minute ago, go to the side, name your power u, and find the derivative. So what's u going to be?
3.
What's u going to be?
3x plus 1.
3x plus 1. So du is equal to 3 dx. All right, but over here, I don't have a 3 and a dx. I only have a dx. So what are you going to do over here? You're going to divide by 3. So you divide by 3 on this side, you divide by 3 on this side. So what I do now, and this part always gets maybe a little bit fuzzy for some of you, is we have an e to a power of u. So we have e to the u power, and then what is dx? It's du divided by u.
Oh.
Not by u.
3.
So that is the same thing as the integral of e to the u over u. Why do I keep doing that? I don't know why do I do that?
I don't know.
Because the natural log has u prime over u. That's what I'm thinking. U prime over 3 du. So what is the integral? What is the integral of e to the u? It's e to the u. Well, we have a 3 out front, which, you know what, let me rewrite this one more time. I'm going to rewrite as 1/3 e to the u du. So what is the integral of this part right here? E to the u. With this constant out front, that just comes along with it. So we have 1/3 e to the u. And now we go back in and replace the u with what u is. U is what is u? What is it?
3x.
What happened to the du?
What happened to the u? The du? Whenever you take the integral, and it has a du in it, once you take the integral, the du disappears. So let me go back to where I defined the integral. Back to the first page. The integral of e to the u du is e to the u. So once you take the integral, the du goes away. That du is there just to tell you that when you find the integral, your integral is going to be written with a u in it. So if it had been a dx here, you would know that your integral is going to be written with an x in it. That du, the du part of it is just there to tell you that that's the variable that you're using in your problem. The d, what does the d stand for? Derivative. So what you're doing here is undoing a derivative in terms of u. So when you take the integral, it goes away. Are we okay with that?
Can you explain it?
Do you want me to go on to another one to see if maybe the next one makes more sense, and then we can? Okay, and I will go back and explain that to you if you want me to. But all right, let's try this one. Let's do the integral. The integral of 5x e to the power of negative x squared dx. So the dx is there to tell you that this is the derivative. 5x e to the negative x squared is the derivative. We need to undo the derivative to come up with the original function. That's what an integral is undo what you started with. Undo what you have to get what you started with. What are we going to call u? Yeah, we're going to call it the power. So u is negative x squared. What is du? Negative 2x dx. So I go over here, and I notice that I do have an x and a dx over here, but I don't have a negative 2. So over here, what do I need to do? Divide by negative 2. So I get rid of that. Divide this side by negative 2. So in this problem, I can replace the x and the dx with a du over negative 2. So this can be written as, I have to keep my 5 there. I have an e to the negative x squared power. What does that mean? E to the u. I haven't done anything with this x and dx yet. What is x dx?
Du.
It is du over negative 2. And now I'm just going to do a rewrite because I don't like how this negative 2 is not over here with the 5. So this is the same thing as the integral of negative 5 over 2 e to the u du. What is the integral of e to the u du? It's e to the u. So the integral of e to this part right here, the integral of that is e to the u, but I have this constant out front, so that is the same thing as negative 5 over 2 e to the u. Now replace your u with what u is, and u is negative x squared. Let's see. Now what I would like to do is, show you that they don't, you know how you took the power, you u is you put u equal to the power and you found the derivative that way. They don't always have to work like that. And you guys have already experienced that a little bit too, that sometimes it's not always exactly the way that you were taught. You have to explore some options, some other options. You're going to have to do something similar to that in this next example. So, any questions on this one first? All right, so another example. Let's do the integral. Now, we're going to do a definite integral this time. So that just means I'm going to give you a top and a bottom. You're not going to add a c at the end of your integral. You are going to find the value of the integral at the 1. You're going to find the value of the integral at 0. And then you're going to do what to the two values?
Subtract it.
You subtract the two. Yeah, it's been a while since we've done that, but I think it will come back pretty quickly. So here's the deal. You have e to the x over e to the power of x plus 1. So at first thought, you might think, okay, well, I'm going to put u equal to the power, which is x. What's the derivative of x? It's 1 dx, and then, you know, what are you going to do? Because the bottom of this is more than just an e to the x power. It's an e to the x power plus 1. So in a situation like this, you're going to want to explore other options. No, we're not going to do the quotient rule. We're still going to do a u over here. We're still going to do a u over here, but any suggestions? What? The bottom. Let's try the bottom. Let's try the denominator and see if we can do something with that. U is going to be the entire denominator. How do you know that? You try it. See if it works. So u is e to the x power plus 1. What's du?
U.
What's the derivative of e to the x power?
E to the x power.
E to the x times the derivative of the power. The power is x. What is the derivative of x?
1.
It is 1. So this is e to the x power times 1, which I'm not going to write down, so it's e to the x dx. Isn't that beautiful? Where do you see e to the x dx?
On the top.
On the top. So this is the same thing as the integral from 0 to 1 of, what is this?
Du.
That is du. Over what?
Dx.
Over
Oh, U.
u. Now, I want to show you something. This is the same thing as, who just said that?
Joe.
I don't like when you tell me that you don't know how to do any of this. Done. Tired of that. What is the derivative of u prime over u? The natural log of u. Get it? Get it? So whenever you get u prime over u, a situation like this, that is the natural log of u. This is the integral. So once we have found the integral, do you remember what you do after it?
Yep, we just plug you in.
Well, when you have these endpoints here, when you're finding a definite integral, do you remember doing this?
Yeah, 0 and 1.
Put your 0 and your 1.
So you want to make it in terms of U?
Yeah, and now what we need to do, well, you could now, at this point, you could go and put this 0 and this 1 into u and change the boundaries. You could do that, yes. I wasn't going to, but you can if you want to. So let's do a rewrite here. This is the same thing as the ln of e to the power of x plus 1, and you are going from 0 to 1. So now what we need to do is find the value of that integral at 1, find the value of that integral at 0, subtract them, and that's your answer. So we do the ln of e to the power of 1 plus 1. Are you still with me?
Yes.
We're going to take this, and we are going to subtract from it the ln of e to the power of 0 plus 1. So I'm taking this thing, replacing the x value with the 1, replacing the x value with the 0, subtracting my answers. Yes?
Did you cancel the ln and the e? No.
Yeah, well, the ln, what is the ln? Yes, it is. It's always, this is going to be equal to the power. Yeah, so this is and I want to show you something too. This one right here, this one, Well, over here I have another plus 1 when I'm gonna be subtracting that in, so I can just cancel those 1s out right now too. And then the ln of e to the first power is 1 minus, what is the ln of e to the 0 power? Should be 0. It's this power right here. So we have 1 minus 0. What is 1 minus 0? 1. So the value of that integral is 1. Okay, hold on, because it's not matching what I have here.
No, that's what
Yeah,
I'm
Miss
saying.
Corrigan.
Yes.
When you put u to e power x plus 1, don't you need to put this?
Parentheses.
Parentheses?
Do you see what I did?
Yeah.
You
Oh wait, what did I do?
Well, I have both of them, not just
Don't you need to put parentheses
around
next
this.
to a e power of x
Ho,
plus
ho,
1?
ho, ho, ho.
Yeah,
Do you see that? Do you see what I forgot?
Yeah.
It is the ln of this whole thing, and I didn't do that. I did the ln of just e to the x, and then I added 1 onto it. It's the ln of this whole quantity, e to the x power plus 1. And then the same thing over here. Thank you, you guys, and I'm sorry. So e to the first power, what is e to the first power? This is looking really messy now. E to the first power is e. Okay, this ends up being the ln of e to the first power plus 1 is equal to, you can't do anything to that, it's just going to be the ln of e to the first power plus 1. This is going to be, remember e is a number, so you're going to have to get your calculators out now, and you're going to have to type into it the natural log of, don't worry about putting e to the power of 1, because putting e to the power of the 1 is the same thing as just having an e, so plus 1, get your calculators out, you got to practice that, you guys. Type in the ln, a parenthesis shows up, type in e to the power of 1 plus 1. Get an answer. I think it's going to be a terrible decimal. Okay. And then we have to subtract from it. What is e to the 0 power?
1.
This part right here. E to the 0 power is 1. So you're really taking the ln of 1 plus 1, which is the ln of 2. So whatever answer you have on your calculator right now, you need to make sure that you subtract from it the ln of 2. What do you get?
0.6.
0.620.
Can you,
Yeah.
Yes.
can you go back a step?
Yes, I will. In fact, I feel like I am going to rewrite. I had ln of e to the x power plus 1. And I had to find the integral from 0 to 1. And I made this mistake of when doing this, I didn't put parentheses around it. I just put the ln of e to the x and then added 1 onto that. So it's the ln of, in parentheses, e to the first power plus 1 minus the ln of e to the 0 power plus 1. So this cannot be simplified at all. So when you type this in, you type in this part exactly the way that you see it. The ln of e. You guys, when you type your e button, does the power button automatically show up? Okay, so you have no choice but to type in a 1 after your power symbol. Are you with me there?
There is an E button.
Depends on what calculator you're using, maybe. You have the yellow ones, you can arrow to the right and get out of the power.
So you put ln into the calculator too?
Yep, you type all that in. ln e to the 0, or e to the first power plus 1. Yeah.
The divide sign for the second function is e. Yeah. The divide sign.
The divide sign.
Divide symbol.
Is
The
that a
divide button, if you do the second quick divide, it's just regular E, not E. It's just an E.
Oh, okay. Did you hear what, is that on the regular black ones too, the old ones?
Yes.
Okay, so if you press second divide, it's just an E, you don't have to use the power then. I didn't know that. Alright, plus this right here, e to the 0 power is 1. So we have 1 plus 1. So you're really doing the ln of 2 here. So this is the same thing as the ln of 2. So whatever you get for the beginning, you're going to subtract the ln of 2 from it. You're going to get 0.620. We should do one more.
Sure.
Alright, this one's not bad, but I feel like we should do it because it has a trig function in it. So we're going from -1 to 0, another definite integral, e to the x, cosine e to the x dx. So, I said to you, call u the power, but if you call u the power, in this case, it's going to be an x, and you've got a cosine in there, u. So that's not going to work in this case. So what you're going to do instead is call u something else. So any suggestions on what we can call u?
E to the x.
E to the x. Probably a good idea. What is the derivative of e to the x?
E to the x.
E to the x, which is, notice, right here also. So probably a good choice. So u is equal to e to the x power. Du is equal to e to the x times 1 dx, which is exactly what I wanted because I have my ex dx over here. So this is the same thing as the integral from -1 to 0 of the cosine of u, du. So what function has a derivative of the cosine of u? I kind of said that backwards.
Negative.
In other words, what is the integral of the cosine?
Sine.
Sine.
What
So in
happened?
other words, the derivative of sine is cosine. Yeah.
What happened to the
Du.
e to the x?
E what? This e to the x?
Yeah.
This e to the x is part of my derivative over here. E to the x dx. Do you see these two right here?
Oh yeah.
These two together make du.
Alright.
So this cosine e to the x is the cosine of u, and then this du is what I replaced e to the x dx with. The integral of cosine of u is, what is the integral again, you guys? Sine. So we have the sine of u from -1 to 0, the sine of u. So now I do a rewrite of the sine of u, which is e to the x, from -1 to 0. Make sure that your calculators right now are set to work in radian mode. And we're going to evaluate this from -1 to 0. So we're going to do the sine of e to the power of 0 minus the sine of e to the -1 power. Type it in. The hardest part about this is going to be typing it in right. E to the 0 power right here, this is 1. So you're really taking the sine of 1 minus the sine of e to the -1. You should get a decimal. I want to know what you got before I tell you what I got.
0.48.
I got 0.482 also. Yep. 0.482.